Our celebration of knowledge is coming. I'm excited. Are you excited? I can barely contain my excitement. I think rainbows are about to like shoot out of my like everything. Everything. Because the celebration of knowledge is coming. So this is on your homework. These are the 5 standards that you're going to be assessed on. Right? It says students know the nucleus of the atom is much smaller, yet contains most of its mass. Can relate atomic number and atomic mass to the nucleus using periodic table. 1H, experimental basis for Thomson's, Rutherford's. These other guys are crossed out. Students know how to use periodic table to identify metals, semi-metals, nonmetals, alkali metals, basically all these families and stuff. Students know how to use periodic table to identify trends in ionization energy, electronegativity, sizes of ions and atoms. Alright, so atomic radius. Students know how to use the periodic table to determine the number of electrons available for bonding. So what I'm going to do is I'm going to give you a quick and dirty just kind of review. Honestly, the best way to review is to do the homework faithfully, which you've been doing, or to rewatch or reread videos, and you can focus in on the ones that you really need help with. Because my like less than 10-minute like crash course that I'm about to give you, it's not going to help you that much. So let's start with A. Let's talk about the atom. Right? So I can draw a model of the atom. I know it's got electrons on the outside. Let's just do lithium. So lithium has 3 electrons. And then we know lithium has an atomic number. I'm looking at the periodic table of 3 and an atomic mass of 7. It's got a 3 atomic number. That means it's got 3 protons. Looks like a face with, I don't know, it's like melting. It's a face in a puddle. Okay, I'm distracted. Atomic mass is 7. I know atomic mass equals the protons plus the neutrons. So that means 7 equals 3 protons plus neutrons. I can get neutrons by itself. So I get 4 equals neutrons. So there are 4 neutrons. Here, I'll do this in a different color so it's more obvious. So I've got 1, 2, 3, 4. So neutrons are red. Right, and so remember this thing right here is called the nucleus. These are called electron shells. The nucleus, so let's actually just type this out. You should probably be taking notes somewhere. Or maybe watch it once and then watch it again and take notes. Nucleus contains all 99.9% of the mass. Right? Electrons have a little, but basically nothing. Did I spell nucleus right? I don't know, guys. It's 12:43 at night. I'm amazed I'm still up. Nucleus contains all, well, I mean, I don't sleep, but, you know, whatever. Of the mass. Electrons are in electron shells. And then I'm already remembering some of the experiments, right? Rutherford's. We're going to talk about that next. But the atom is mostly empty space. Okay. I think that's the basics. Next one is experimental basis for Thomson's discovery and Rutherford's discovery. So I remember Thomson's, he had his cathode ray tube, right? His big old tube. And then he used a high voltage, so like electricity, and he had stuff come out, and then he put like plus and negative, and it like curved towards the plus, right? And so this was how the electrons was discovered, because the electrons, you know, electrons attract to positive, and all atoms did it. They all released these tiny particles, and these particles could go through foil, right? Like they could pass through stuff, and so they must be really tiny. But they must be negative too, because they're attracted to the positive. And then Rutherford's experiment, I remember he had a gold foil, right? Got to get my bling. He put his bling over here. Then he shot these alpha particles, these alpha particles are positive, remember, because it's a helium nucleus, so it's these 2 protons and then 2 neutrons. And they're pretty, and most of them just like pow went right through. It was like 99% of them or something. But then some of them bounced or were deflected. Just, wah. So that was like 1% bounced. And so he was like, what the heck? Why are they bouncing? And so what he decided is the ones that bounced must have been repelled by something. Well, hold on a second, because the alpha particles are positive, right? So if they're getting repelled by something, the something must be positive and dense. Because if it didn't have a lot of mass, it would just get pushed out of the way. Because these alpha particles, they have 4 mass, right? They have 4 particles here. So it must be something positive and dense, and he decided to call this thing the nucleus. Bum, bum, bum. All right. You can also look at Chadwick's if you need to review that. These ones are the most essential. What else? Okay, the different metals, semimetals, nonmetals, alkali metals. Okay, great. So if I sketch the periodic table, I can do that. This is fun. It's very, it's a little damaged of a periodic table. Don't forget the lanthanides and actinides. These ones go in, like, right there. Okay, so we've got these different sides. I remember there's this staircase that goes down, like, here. Anything that touches here are the semimetals. And then I remember the left side is the metals, except for hydrogen. It's a nonmetal. And then this side over here is the nonmetals. Remember, nonmetals, nonmetals are brittle. What else? They're insulators. They're dull. Metals are shiny. They're basically the opposites, right? They're malleable, or they're not insulators. What's the opposite of insulators? They're conductors. That's right. And then semimetals are just like in between. Okay, and then the family names, I remember group 1, alkali metals. Group 2 is alkaline earth metals. And then here, these are the transition elements or transition metals, since they are on the left side. This group 7 is the halogens. These are the noble gases. These down here, I don't think I ever actually taught you, but they're called the lanthanoids. Lanthanoids. And then the last one down here is called the actinoids. Just a fun fact. I don't think I taught that, so I'm not going to assess it. But, I bet one of you wanted to know that. What else? Trends in ionization energy. All right. I should just copy this periodic table. Doot, 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 doot. Oh, I missed one. Darn it. It's okay. We'll just fill that guy in right here. There we go. Magical. So, periodic trends. I remember there's 3 of them. First off, we should define them, right? Atomic radius is the size or distance between nucleus and valence electrons. Electronegativity is how well an atom attracts electrons. And then ionization energy is how much energy it takes to remove an electron, aka how hard it is to remove an electron. Okay, so I remember when you go up and to the right, that's where electronegativity and ionization energy is high. And then if you go down and to the left, that's when the atomic radius is high. And then if you go the opposite way, so like here, going up, electronegativity and ionization energy are high, atomic radius is low. As you go down to the left, atomic radius is high, electronegativity and ionization energy are low, 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 low. Gotta get low, low. And so then if I give you, two elements here and here, you should be able to discuss the differences. And then something with a high electronegativity is going to tend to take electrons because it's stronger. Last one, number of valence electrons available for bonding. That's easy. So you just go back here and just count off. 1, 2, 3, 4, 5, 6, 7, 8. And then you just, which group is it in? That's how many valence electrons it has. And if they have the same number of valence electrons, they're going to react similarly. Okay. That's all I'm doing for this video. You're not done reviewing, though. You're really not. Look at your action plans. Figure out what failures you had on homework. Right? Check your answer key. Check the answer key in the room. Figure out what do you need to study more. What do you need to focus in on so that you can destroy this celebration of knowledge like the fabulous person you are. I'll see you in class. Stay beautiful.